Hello students, welcome to Rasaayana Institute of Sciences. In this session we are going to begin a most important unit for chemistry purpose. Without this unit you cannot understand chemistry, let it be organic, inorganic or physical chemistry, because this unit is the heart of chemistry. Hope you might have understood regarding what topic that I am going to tell. This is chemical periodicity. So without knowing what are the elements present in different blocks, without knowing what are the trends that are present in the physical properties and chemical properties, you cannot understand the chemistry of the elements or the compounds or molecules, whatever you choose, that is regarding to the organic chemistry or inorganic also. So in this session what I am going to begin is, first of all, how to write a periodic table, because to get the chemistry of 2 years, or let it be the higher years +2, or let it be your degree level or PG level, or wherever you go, chemistry is highly important. So to understand all this chemistry, today we are going to discuss about the various elements that are present in the modern periodic table. First, let us write what are the elements present in the modern periodic table. Once you are aware of the elements that are present in this table, then slowly we will move to the classification of the elements. Who have classified the elements into what types, what is the history, where did it start from, and where did it end. All that we will be studying in our next class. But first of all, we have to understand how to write the elements in a periodic table. So altogether, you know that there are 118 elements in the periodic table. Up till 100 elements we can write along with their symbol, but after 100 IUPAC has given a simple labeling. Suppose if it is 0, we take it as nil, if it is 1 we take it as un, and so on. But those elements have also been named. So in this session we are going to name the elements starting from 1 up till 118. And also we are going to take the IUPAC nomenclature starting from 101 to 118 elements. Okay, so let us begin our journey. This is the most important unit and the very first unit. We call it as chemical periodicity or periodic classification of elements. We are classifying the elements periodically according to their properties. What type of properties do we choose to classify these elements? All those things we have to understand in this unit. As I told you, altogether there are 118 elements. There are 118 elements in the periodic table. Okay, so first of all let us write all these elements without seeing. That will give you a lot of confidence. Without seeing it will take a little time, maybe 1 week or maybe 2 weeks, but definitely you have to practice writing the elements right from 1 to 118. Even if you don't remember the elements up to 118, you should be able to remember the elements which are present in S block, P block, D block and F block. For D block it is 3D, 4D and 5D. So even if you want to forget 6D, that is the only series which you can forget. But my suggestion is try to remember all the elements. That will give you a lot of confidence in your chemistry. Okay, hardly it will take 1 week of time. With regular practice maybe of half hour to 1 hour is more than enough for you. Just write the elements according to their groups. Remembering right from 1 to 118 is difficult for some of us, so rather you better remember it in the groups. Okay, S block, what are the elements? P block, what are the elements? And likewise D block, what are the elements? For F block there are lanthanoids and actinoids, so directly we write it in periods. Okay, periodically, right? So now let us write the elements. I am just starting from hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These are the beginning elements. First of all, I'll write all these elements, then later we will number it. So these are the elements that are related to S block. We have P block in this. We also have D block in this. Okay. Along with this, we also have F block elements which are written separately. So before writing them, let us just number. The numbering begins with hydrogen 1, 3, 11, 19, 37, 55 and 87. So once we are aware of these numbers, then we can simply write across the period. So what are the numbers that we are going to write across the period? Here I am going to put 4, and this will be 5, 6, 7, 8, 9 and 10. Helium is 2. Okay, this should be easier for you. Later on we started with 11, then will be 12, 13, 14, 15, 16, 17 and 18. Potassium is 19, so later we continue from 20. I will also read these elements so that you will get a understanding. See, writing a periodic table without saying it will give you a lot of confidence, as I told you in the beginning. It will be like you are aware of whole of chemistry. Right? No one can touch you in chemistry. Well, when I write 57 here, after lanthanum we have lanthanoids. So after 57, 14 lanthanoids are present, starting from 58 to 71. So 71 will go to lanthanoids, therefore we start from 72 here. What happened to the remaining elements? That will come as lanthanoids. Again, after actinium we have actinoids. There will be 14 elements, so those 14 elements will continue up till 103. Therefore Rutherfordium will take 104. So this has given you a complete picture of S block, P block as well as D block. Later we'll try to write the lanthanoids. We'll try to number them. From 56, 57, so this will be 58. This will continue up to 71. So here we stopped at 89. Thorium will be 90. So this is the complete periodic table. So now let me just read out the elements for your convenience. Suppose I take the beginning elements. This is group 1, group 2, group 3, group 4. We continue up till group 18. Altogether there are 18 groups according to IUPAC. But if you go for the American nomenclature, we have 1A, 2A and so on. Those two different types of classifications we'll discuss in the next classes. But let us read out the elements. In the first group we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. The easiest way to number is 2, 8, 8, 18, 18, 32. You just remember these elements. 2, 8, 8, 18, 18, 32. If you can remember these numbers, the difference between hydrogen and lithium is 2. The next difference will be 8 elements. The next difference will be 8. Next difference will be 18. Next difference will be 18. Then difference will be 32. So 1, everyone can remember. You just remember 2, 8, 8, 18, 18, 32. So accordingly you write these numbers. Once you get the first group numbers, then all the remaining numbering is very, very simple. Okay. Let us look at the second group. Beryllium, magnesium, calcium, strontium, barium and radium. Right? You may develop your own mnemonics. How to remember those elements? You may remember your own mnemonics that we will be discussing in the next classes. But this is just an introductory class. You should be knowing what are the elements present in the periodic table. Okay, so let us continue. Scandium, yttrium, lanthanum, actinium, titanium, zirconium, hafnium, rutherfordium, vanadium, niobium, tantalum, dubnium, chromium, molybdenum, tungsten, seaborgium, manganese, technetium, rhenium, borium, iron, ruthenium, osmium, hassium, cobalt, rhodium, iridium, meitnerium, nickel, palladium, platinum, darmstadtium, copper, silver, gold, rhonginium, zinc, cadmium, mercury, copernicium. So up till this level D block elements are completed. First group and second group, they belong to S block. Now from here to here, 3rd to 12, it is D block elements. Later on, let us study about the p block elements: boron, aluminium, gallium, indium, thallium and nihonium; carbon, silicon, germanium, tin, lead, flerovium; nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium; oxygen, sulfur, selenium, tellurium, polonium, livermorium; fluorine, chlorine, bromine, iodine, astatine and tennessine; helium, neon, argon, krypton, xenon, radon and oganesson. So oganesson is the last element, 118. Let us also study about the lanthanoids and actinoids. There are different names given for them: lanthanones, actinones, lanthanides, actinides, but we can better call it as lanthanoids and actinoids, or lanthanones and actinones. So what are these lanthanoids and actinoids, or lanthanones and actinones? Starting from cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium and lutetium; thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and lawrencium. So these are the elements belonging to the F block. They are given a separate space, not in the main periodic table. Okay. The next point to remember, we will be taking up a detailed classification, but just a 2-minute brush up. All S block, they are purely metals. All D block elements, they are also purely metals. But when it comes to P block, in this P block we have metals, we have non-metals, we also have metalloids. Okay, so P block is very unique, because if I take care of the oxidation states, the oxidation states you will be finding is variable oxidation states. Those oxidation states also we have to discuss as a property. But in this case, let us just understand about the various metalloids. Boron, five metalloids were considered in the beginning, later on 7 were considered. Now even astatine is also considered as a metalloid. In some literature, astatine is not given, they are given up to polonium, tellurium, polonium. So boron, silicon, germanium, arsenic, antimony, tellurium and polonium are given as metalloids. In some literature, astatine is also added, so we will also consider astatine. Altogether there are 8 metalloids. The remaining are non-metals, metals, lanthanoids and actinoids are also purely metals. So our periodic table is out and out dominated by metals. Okay, right. Hope you have understood how to write and how to remember them. You remember them group wise. That is very, very convenient, and numbering is also very convenient. When you begin for first group, remember 2, 8, 8, 18, 18, 32 is the difference between the corresponding elements of the first group. 2 difference is 2, 8, 8, 18, 18 and 32. Okay, so I told you up till 100 elements the namings are given, different symbols are given, but from 101, instead of directly naming them with the element symbol, we also have IUPAC naming. So let us also understand that IUPAC naming. For that IUPAC naming, we have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 is represented as nil, 1 as un, 2 as bi, 3 as tri, 4 as quad, 5 as pent, 6 as hex, 7 as sept, 8 as oct, 9 as n, e double n. Nonna is 9, ennea is also 9. So instead of taking nonna, they have considered n, e double n. Ennea is 9. Nil, un, bi, tri, quad, pent, hex. Instead of giving hept, 7 can also be like hept. In your organic chemistry, you will be getting it as 7 carbon chain heptane, 7 carbon alkane. But here instead of given hept, they have given sept. The simple reason is here we already got a H. So not to repeat it, therefore they have given it as sept, September, sept. It is like a 7th month according to the Indian tradition, oct and n. So based on this, let us write the elements. Starting from 101 to 118. Always remember, whenever we are naming a particular element, IUPAC has given two different guidelines. One guideline, what is the prefix to be used? Prefix for that particular number is nil, 0 if I get is nil. If I get 1, you write it as un. If I get 2, you write it as by. When you write all these prefixes, later on the name must end with IUM. IUM. So whatever may be the element starting from 101 up till 118, the name has to end with IUM. Okay, let us understand how to write it. Suppose if I am taking 101 element, this is un, 0 is nil, 1 is un, element should end with IUM. So we call it as unnil unium, unnil unium. Second one, un, nil, bium, bium, but you can omit one I. Okay, according to IUPAC, un, nil, bi and IUM. So 2 times I is repeating. You can remove one I. You can directly call it as un, nil, bium. Later we have un, nil, tri, IUM. You are removing one I. It will become trium. Un, nil, trium. You need not say un, nil, tri, IUM. Later we have un, nil, quad, quadium. Un, nil, pentium. Un, nil, hexium. Un, nil, sept. Un, nil, septium. Un, nil, oct. Un, nil, octium. Un, nil, n. Un, nil, ennium. The last one is un, nil, un, nilium. This is up till 110. Later on, we'll also take up from 111. Nil will not come. It is like un. Every time un will repeat. Un, IUM. Un, unium. Un, bium. Un, tri, IUM. Directly I write it as un, trium. Un, quad. Un, quadium. Un, pent. Un, pentium. Un, hex. Un, hexium. Un, sept. Un, septium. Un, oct. Un, octium. So these are the elements according to IUPAC nomenclature. I just repeat. For IUPAC nomenclature up till 100, the simple elemental symbols have been given. From 101 to 118, we have different type of labeling. For 0 is nil, 1 is un, 2 is bi, 3 is tri, 4 is quad, 5 is pent, 6 is hex, 7 is sept, 8 is oct, 9 is n. Accordingly, we have 101 to 118 elements. In that we have unnil unium, unnil bium, unnil trium, unnil quadium, unnil pentium, unnil hexium, unnil septium, unnil octium, unnil ennium, and unnun nillium. That is up to 110. From 111, unnun unnium, unnun bium, unnun trium, unnun quadium, unnun pentium, unnun hexium, unnun septium, and unnun octium. So this is all about the writing of periodic table. Without seeing, we have written the complete periodic table. In that periodic table, this was the periodic table we have written. You should have enough confidence to write a periodic table without looking at it, and also numbering the periodic table without looking. So I told you in the beginning, it will hardly take 1 week or 2 weeks for you to practice, and the best way to practice is write according to the groups. So all the 18 groups, if you can remember, it will be very easy and it will give you a lot of confidence also. Okay, so this is only a beginning. Later on in the sessions, we will be seeing what are the various types of classifications, such as how the metals were classified into metals and non-metals. Later, what is law of triads, or later we have law of octaves, Mayer's curves, Mendeleev's periodic law, Mosley's periodic law, and who has finally given the periodic table that we are following. What are the different types of classifications, such as SP, DF block type of elements, or we have right portion, left portion, middle portion, and bottom portion. All these things will start in the next session. Okay, so prepare well, try to write the periodic table without seeing, have that confidence. Okay, we will close this session. Thank you.